Hello once again, everybody. Welcome back. We're going to be continuing on with the 2009 Fryer contest. We already saw questions 1 and 2 in the previous videos. Let's take a look now at question number 3. So, in the diagram, K, O, and M are the centers of 3 semicircles. Big one, and this shaded one. Also, OC is equal to 32, and CB, so that's the diameter of this smaller semicircle, is 36. So we have 4 parts to this question. Let's take a look. A part, what is the length of AC? So the diameter of this, the medium-sized semicircle. Okay. Let's get ourselves a brand new piece of paper. We'll draw ourselves a little copy of the picture. Right. So we're up here. Here's our big one. And we have this tiny little one over here. C, B, M. And we have a slightly bigger one with center K. We have A over here, and somewhere in here we have O, 32, and this length here is 36. So we have the radius of the big semicircle is OB. Well, we can calculate OB right away. OB is OC plus CB. And we were given these lengths at the start, 32 and 36. So that's 68. Okay, so the big circle has a radius of 68. Incidentally, the small circle has a radius of a half of 36. We're adding just a little bit more information about the picture as we go along. So we know that OB is 68. Now OA is equal to OB, which is 68. And we want AC. Well, AC is OA plus OC. We know these two values now. 68 plus 32 so AC, which is the diameter of the medium circle, is 100. So we have the radius of the medium semicircle. But above all, we were asked for AC, which is 100. So let's sort of highlight that a little bit. We have 100. So that's A part. Nice and simple. Just a little bit of diagram chasing. Alright, B part. What is the area of the semicircle with center K? Okay. Well, we just figured out the radius a second ago. Radius is 50. So half the area of a circle is the area of a semicircle. It's 1/2 pi r squared. Well, we know what r is. It's 50. 1/2 pi 50 squared, and that comes out to be 1250 pi. Very simple. We took stock of all the radii as we went through part A, and that made part B very, very quick. Alright, what is the area of the shaded region? Well, the shaded region is the big semicircle, and then we take out the two smaller semicircles. So if we were to figure out the area of the big semicircle and subtract out the area of the smaller semicircles, we'd be all set. Well, fortunately in B part, we figured out the area of the medium semicircle. So what were those radii again? Radii were 68, 50, and 18. Okay. So we want 1/2 pi 68 squared, 1/2 pi 50 squared. We know that one, that's 1250 pi. And 1/2 pi 18 squared, so that's going to be 1/2 of 324. So that's going to be 162 pi, and what was that first one? 68 times 68. Divide that by 2. 2312 pi. So the shaded region has area 2312 pi minus, minus 1250 pi minus 162 pi. So what's that? That's 2312 minus 1250 minus 162. That's 900 pi. Nice little number. All right. So that does it for that question. So let's take a look at the rest of the question. So D part. Line L is drawn to touch these smaller semicircles at points S and E. Okay, so he's tangent to these two smaller semicircles at S and E. So that KS and ME are both perpendicular to L. So that's exactly what that means. Determine the area of quadrilateral KSEM. Okay. So let's draw a little bit of a picture. So I will assume these guys touch, even though my diagram is not the best. That is just awful. Awful, awful, awful. We can do so much better. Alright, so K down here, M here, and E here. So we know these guys are perpendicular to the line SE. We also know that this is going to be 18. This is a radius, so this is 18. This is 50. This is 50. We don't quite know what SE is. And we're asked for what? The area? The area of KSEM. Okay. Well, we could leave it like that in our diagram, but really what we could do is pull it out a little bit. And reorient it so the perpendicular ones are on the bottom. (18 plus 50), we have 18 over here, we have 50 over here. So what we can do is we can break it up. Instead of just trying to figure out the area of this quadrilateral, what we can do is break it up into the area of a right angle triangle and the area of a rectangle. All we need is this length x. So being a right angle triangle, we know that MK is going to be x squared plus, we'll call this point D, plus KD squared. Okay, and KD, well, that's just going to be 50 minus 18. Remember, 18 of this length 50 is taken up by the rectangle. We want the right angle triangle right now. So that's going to be 68 squared is equal to x squared plus, and what's 50 minus 18? It should be 32. Yep. So 32 squared. And this looks like an 8, 15, and 17 triangle. So that's another number 17 for you. So 68 squared minus 32 squared. So that's 4624 minus 1024. So that's 360, or 4 times 15. So x equals 60. And from there we can figure out the area of this rectangle. It's going to be 18 times 60. And then this triangle here, it's going to be a half base times height. So 16 times 32. What was it? No, it's not K, it's M. MDSE. So that's 1/2 base times height, plus length times width. So that's 60 times 16, 960, plus 60 times 18, 1080. And we add those two together. We get 2040. And we make a little therefore statement. Quadrilateral is 2040. So That gives us the answer to D part. Got the area of our quadrilateral. We're all set. There's nothing else to do in question number 3. That concludes it. Nothing more to say, so I'll see you guys in the next question, which is question number 4. And that'll finish off the 2009 Fryer contest.